Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next module number MECH underscore P underscore 074 underscore Douglas C. Gyan Kuli. Statement: determine the stopping distances from an automobile with an initial speed of 95 km per hour and human reaction time of 1.0 second. Determine the stopping distances for an automobile with an initial speed of 95 km per hour and human reaction time of 1.0 second. Part A: for an acceleration A equal to minus 5.0 meter per second square. Part B: for an acceleration A equal to minus 7.0 meter per second square. Okay. Solution. Dear students, first we bring our data in a concise form in which some things are given and some things are to be known, to be determined. Okay, so here we see what quantities are given and which quantities are to be known or determined. Okay, so let us summarize the given and required data as: initial velocity v naught equal to 95 km per hour. First we will convert it into meter per second. Okay, so first we will replace kilometer by 1000 meter and replace hour by 3600 seconds. Okay, so in this way initial velocity v naught will alternatively become equal to 26.39 meter per second. Okay, final velocity v is given as 0 because it is given that it comes to rest. Okay, time t is given as 1.0 second. Okay, x naught is to be determined. Similarly, x is to be determined in two cases. In first case, when acceleration given is minus 5.0 meter per second square, and second case when the given acceleration is minus 7.0 meter per second square. Okay, so initial and final velocities are given and time is given, while x naught is to be determined and x is to be determined twice with two given acceleration values. Okay, when we will solve for acceleration a equal to minus 5.0 meter per second square, it will cover part A of our problem. Okay, when we will consider acceleration a equal to minus 7.0 meter per second square, it will cover part B of our problem. Okay, so first we find x naught. Okay, x naught is equal to v naught into t. This expression is sometimes can also be written as s equal to vt, that is displacement equal to velocity into time. Okay, so x naught is equal to v naught into t, V naught is given as 26.39 meter per second, while time is given as 1.0 second. So x naught alternatively becomes equal to 26.39 meter. Okay. Now we move on to next slide. Now we will find x. We will find x for two cases. Okay. Here we are considering the first case when the value of acceleration is given as minus 5.0 meter per second square. Okay. Using the equation of motion, square of final velocity is equal to square of initial velocity plus 2ax minus x naught. Okay, this implies that 0 is equal to 26.39 meter per second whole square plus 2 into minus 5.0 meter per second square into x minus 26.39 meter. What we have done? We have simply put the values in their required place. Okay. In place of v we have used 0. In place of v naught we have used 26.39 meter per second. In place of acceleration a we have used minus 5.0 meter per second square, and in place of x naught we have used 26.39 meter, which we have calculated in the previous slide. Okay. This implies that x minus 26.39 meter is equal to 26.39 meter per second square into 1 over 2 into 5.0 second square per meter. Okay. Here, when we keep x minus 26.39 meter on one side, then 2 into minus 5.0 meter per second square will become with plus sign, because it will become with plus sign because here it is in negative sign, and moreover it will be reciprocated, it will be inverted. Okay, it will become 1 over 2 5.0, and instead of meter per second square it will become second square over meter. Okay, this is quite simplification. There is no need to explain it. It is of a lower classes level simplification. Okay. This implies that x minus 26.39 meter alternatively becomes equal to 69.64 meter. Okay. X minus 26.39 meter is equal to 69.64 meter, and hence this implies that x will become equal to 26.39 meter will become plus on the other side of equality. Okay, and these two factors will be added. Okay, 26.39 meter plus 69.64 meter, and hence this implies that x finally becomes equal to 96.03 meter. Okay, x has become equal to 96.03 meter, and this solves part A of our problem. Now we move on to next slide to see solution of part B, in which we will consider value of acceleration as a equal to minus 7.0 meter per second. Okay, remaining part will almost be quite similar. Okay, B, x For a equal to minus 7.0 meter per second square. Okay, this is going to be determined using the equation of motion. Square of final velocity is equal to square of initial velocity plus 2ax minus x naught. This implies that 0 is equal to 26.39 meter per second whole square plus 2 into minus 7.0 meter per second square into x minus 26.39 meter. This implies that x minus 26.39 meter becomes equal to 26.39 meter per second whole square into 1 over 2 into 7.0 second square over meter. Here the complete previous procedure is repeated. Okay, so it is quite unnecessary to explain a simplification of this stuff. Okay, this implies that x minus 26.39 meter becomes equal to 49.74 meter, and this implies that x is equal to 26.39 meter plus 49.74 meter. Okay, these two factors will be added and hence x becomes finally equal to 76.13 meter, and this solves part B of our problem, and this is the end of our module. Okay.